Calculating the E cell, again a very common electrochemical problem is if you're given both the cathode anodes or the equation, then you calculate the E cell for it. And again, you need the data tables for it, so feel free to use those. So here is the first problem. Determine the E cell for the following reaction. So here you have aluminum plus copper ions to give aluminum 3 plus and 3 copper ions. So not copper ions, but just copper. So then we have to look for our equations over here. So we separate them out. And aluminum is aluminum 3 plus 3 electrons. And then copper 2 plus is adding on 2 electrons to give copper. This is really what's going on as far as the equation is concerned. Okay, and so then what we're going to do is we will go ahead and write out our numbers from the table, the data tables. Now remember again that everything is given to you as reduction potential, okay, which means addition of electron, whereas this is actually the opposite thing going on. Okay, so I'm going to show you two ways of doing this. But the reduction potential for aluminum is equal to minus 1.676 from the chart, and the reduction potential for copper, which is fine because this is reduction going on for copper, is plus 0.34. Okay, that's what's happening here. And according to what our equation is, we have to stick to that. Okay, we don't have to worry about whether the reaction is spontaneous or not. That's not our problem. The problem is that if you have this reaction, what is the voltage going to be, okay, for this? So I'm going to do this two ways for you. One is the traditional way that you know of, which is E cell is equal to E cathode minus E anode. And so this one, the cathode here, is where the reduction is taking place, okay, and so which is going to be our copper. So that is 0.340. Okay, so you really need to know this. So this is cathode. This is the cathode. This is the anode. As the loss of electrons occurs at the anode. Minus, and then minus 1.676. Okay, and then you do the calculation, fairly simple, and you get 2.016 volts, and that is the E cell for this equation. The other way to do this, second way, and again you don't have to do this if you don't want to, this is how I learned to calculate E cell and this is using the aluminum equation. Okay, since aluminum is getting oxidized, I will reverse the charge on the E naught. Okay, so it is actually plus 1.676. Okay, because what is given to me is the reduction potential, and what I'm doing is oxidation, so I will inverse it. Okay, and then my E cell is E cathode plus E anode. So once I know what those two numbers are, that's what I have to do, which is really what I am doing in the first method also. But here I've just already done one calculation, so 1.676, and I will still get the same answer. Here I already have the plus, and here I had to calculate the plus, okay, using this. So it's up to you, whichever one you want to do, it doesn't matter. Once you know your cathode and your anode, you're all set. Okay, and so long you keep your charges straight, you should be fine. Let's look at one more example. Determine the E cell for 2 nitrate plus 3 lead 2 plus and water to give 2 nitrogen monooxide and then the lead oxide. So for here we have to separate out the two equations. So we go ahead and look at the data tables, and you will find the equation there for lead 2 plus to give lead O2. And so here lead is actually going from 2 plus to 4 plus, which means that it is losing electrons. So it's plus 2 electrons, which means that this is my anode. Okay, and this anode, the E cell for this, or the E naught for this, from the data table, the reduction potential is 1.4 1.455. My other part of the equation is 2NO3 to give 2NO. And here the nitrogen is getting reduced because obviously you are losing oxygen. But here we don't have to worry about balancing equations, so don't worry about that. Once you know at least one thing, then you know the other one is going to be the cathode, okay, or wherever the reduction is taking place. The E naught, or the reduction potential for this one is plus 0.956. Okay, so it's really again important that you know your cathode and your anode. So your E cell is your E cathode minus E anode. Okay, so that's 0 point. Cathode is the nitrate, okay, which is, or excuse me, nitrogen, it is nitrate, NO3 minus nitrate, and that is 0.956 minus. For the anode then, now minus anode, this time the anode is positive, so positive 1.455, and then this is going to give us minus 0.499 volts. Okay, that's what it is going to be. Now if you wanted to do it the second way, it's easy. Inverse the anode, because that's where the oxidation is taking place and you're given the reduction. So minus 1.455 and then add 0.956, because you add the cathode and the anode and you should have the same answer. So it's really up to you which one you want to do. It doesn't matter to me. Just make sure you get the right answer.